In the pipeliner example, we rejected the hypothesis that there was a statistically significant similarity between the two means. That's an awkward way of saying, hey, we had a null hypothesis that said that between the no fusion and fusion process, the two means were the same. And at the 5% significance level, we rejected that. But at the 1% level, we couldn't reject that. And then we went on to demonstrate that that if we had instead looked at a null hypothesis of mu1 minus mu2 equal to negative 100, we wouldn't be able to reject it at either the 5% or 1% significance level. So we're going to continue to look at that data and instead now look at it from a confidence interval standpoint. Now we could have introduced confidence intervals for the differences in means back in that whole segment where we talked about confidence intervals for just a single sample. We chose not to, only for the consistency with your Montgomery and Runger text and how they organize material. But you'll find a lot of authors decide to put all that together. Right? And so for this case of a two-sided interval, we could do one-sided, but because we have this interesting problem of having already thinking that we're going to reject or we're going to reject if there's any real difference going on here, even though we wanted there to be. I'm going to go look at a two-sided one, just really more than anything to illustrate the process. Right? And the upper and lower bounds for the differences in our two means can be found from first looking at the differences in the sample means, and then plus or minus the z alpha over 2. Now this is just a general one here, and we're going to broaden this out in a moment for a different set of conditions. And then we're going to take square root of some of the squares of the variances of our population measures. Right, so this is the same kind of thing that we've seen before, that z is the number of standard deviations away from a mean. That's all this stuff back here, and here's our mean of the difference, expected value of the difference, right? And if we have then unknown variance, but if they were the same, then we'd replace that z alpha over 2 with a t alpha over 2, right? And then of course that means that we're going to come in and we're going to replace the population measures with our sample measures, right? If we think that the population variances are the same, there's an easier, simpler way to get the degrees of freedom. But if they're not the same, and we don't have any reason to believe that from the two populations that they would be the same, then we go about it exactly the same way that we talked about before. And that is basically the same as we did for the hypothesis tests. And that's a pretty complicated looking expression that we'll leave just sitting there. It's not going to change, so we'll just kind of leave it alone. Okay. For our example HT 3.1, then a 95% confidence interval on the difference in the two means, right? That's the no fusion versus fusion for the tensile strength of those pipeliners, right? And go back and find that our degrees of freedom for that case were 15, right? We had unknown and presumably unequal variances. We also had small sample sizes as well. Right? So for degree of freedom equal to 15 and 95% confidence interval, go look in our table for our t alpha over 2 value. Remember, that would be 0.025, right? We're going to split the difference of what's left over. So 2.131. And our interval then is going to become minus 205.3, right? That was the difference between the two sample means, plus or minus 2.131 times 113.97. That was this guy right here, square root of the sum of the squares, and so that had the sample variances thrown in there. Okay, and this number here is 242.9, and that will lead us to a confidence interval for the difference, a two-sided confidence interval for the true mean of minus 448 and up to 38. It's this 95% confidence interval and the difference of the true mean that oftentimes is going to get reported in Minitab and other associated statistical software. When you hit the button for the hypothesis test, they'll typically report this one right here. Hence, that was the real reason I went ahead and showed this to you. Okay. What this also tells us is that, gee, the confidence interval includes that zero value, right? So we could go to a lower confidence and shrink that down. That would be one approach to going. But when you look at that in conjunction with the other numbers that we were getting, it all suggests that we just don't have a lot of information to reject this notion that the two means are equal to each other. And that leaves the question of, well, what do we do? Do we go ahead and accept the 5% significance test and its findings, or do we not? Do we report something else? Well, we can certainly report that, but what do we do? And what we're going to do in our next little mini module is to look at the probability of a type 2 error. That is, and we'll that complement the information we have to make a final decision about what to do about this data.